Okay. Uh, Alright. I think a lot of people should actually at least know the difference between a program and a process, because some people struggle to differentiate between the two. So a program is just, you can think of it as a C program that prints hello world. It's a sequence of static instructions. A process is, you can think of it as a bubble that represents the instance of your program, but within that bubble there's a lot of things that happen in the background. For instance, to actually print something to the screen, your program has to go into kernel mode and then go to the bottommost instruction on your computer to actually throw an interrupt and actually print something on your screen. So all of that happens is the process. Um, so a process, you have some program, compiled program in your hard drive. This is in the context of Windows. That's why I have exe and not an else executable for Linux. So binary.exe is loaded from your hard drive into your RAM. Now the CPU is actually able to fetch instructions from the RAM, decode, and execute. So the CPU is the brain. I'm assuming you know that stuff is kind of pretty basic stuff. So your process, this is in the context of Windows, but it's very similar with regard to all other operating systems. So a process, remember that one big bubble, it contains a private virtual address space. So I'm not gonna get too deep into this, but basically your physical memory, your operating system doesn't just hand out random pieces of physical memory. That's risky, right? You can overwrite parts of physical memories, or they don't give you little sectors of physical memory. No, they give you a virtual memory address pool for your program. Your program gets a virtual, a virtual memory address pool. So basically, you can think of it as a pool from the physical memory, but it's virtual. It's sort of like a, fuck these headphones. Okay, anyways, it's sort of how do you say it? How do you say it? It's not the exact physical memory. It's not even the virtual memory. Is not real memory, but it's tied to the physical memory. If that makes sense. I'll explain better in the next video, or two videos, whatever. It has a executable program, so that's your program. It's the actual data and the code that is mapped to the virtual address space. And a PID just uniquely identifies the process on the Windows operating system. Same with Linux. Um, and there's a security context. So your program has an access token, which tells the operating system essentially what privileges it has. So your process should not be able to access administrator system memory address spaces, or should not be able to request a file it does not have access to. If it's not in kernel mode, if it's a user mode program, it should not be able to do kernel operations. Like a device driver is a kernel mode system, the device drivers on your system that interact with your hardware, obviously, because they need to be as low level as possible. And I'll explain the kernel and stuff more future videos. But basically, it protects your computer and it makes sure your process doesn't have access to things it shouldn't have access to. I'll get into more detail. And finally, a list of open handles. So these can be files, these can be system objects. Maybe there's a library or function in a DLL file and it opens a handle to that. Basically, you can think of it as accessing different system resources to perform operations in your process. Actually, yeah, I guess that's it. Just know this though. Make sure you know the difference between a process and a program. And know that a program is what we will actually be reverse engineering most of the time. The program is what we're going to target, the code that is written by the developer or engineer.